This lesson is about how to simplify algebraic radical expressions. First, let's review some definitions. The index of a square root is 2, the index of a cube root is 3, the index of a fourth root is 4. You see the index number just outside of the square root. Normally the 2 is invisible, but here the index is 3, and here the index is 4. The index number tells you the type of root that you're doing. Again, square root, third root, fourth root. We often take roots of algebraic expressions, such as these. The most efficient method for handling roots like these is to rewrite each number inside the radical symbol in terms of its prime factors. So for instance, 25 is actually 5 squared, 27 is actually 3 cubed, 16 is actually 2 to the fourth. We could have written 16 as 4 squared, but we'll prefer 2 to the fourth because the index is a 4. Then, provided that all the exponents within the root are divisible by the index number, you can simply divide each exponent by the index number in order to simplify the root, and the root symbol goes away. So notice, in this example, it's a square root, so the index is 2, so I divide each exponent by 2, and it simplifies to 5 to the first, x to the first, y to the second. Here, the index number is a 3, and each exponent is divisible by 3, so it simplifies to 3 to the first, x to the first, y to the second. Here, the index number is a 4, and every exponent is divisible by 4, so it simplifies to 2 to the first, x to the first, y to the third. This is simplifying an algebraic radical expression. The product rule for radicals states that the root of a product is equal to the product of the roots. For example, root m times n is actually equal to the square root of m times the square root of n. Consider the example root 50. You can rewrite 50 as 25 times 2, so you can break apart the root and make it root 25 times root 2, and you can simplify root 25, so this expression actually simplifies to 5 root 2. You could also use the product rule to simplify root expressions when the exponents are not divisible by the index number. You will split the exponent into a part that is divisible by the index number and the remainder. For instance, root 125. 125 is actually 5 cubed. Now I can split 5 cubed, which is really 5 times 5 times 5, and I can split it into the first part, which is root 5 squared, and the second part, root 5 to the first, and then the first part simplifies. Because it's a square root, the index is a 2, 2 divides into the exponent 2, that part simplifies to simply 5, and then the second part remains inside the root. So your answer is 5 root 5. Consider this next example with a variable. The square root of x to the fifth. I rewrite x to the fifth, which is actually x times x times x times x times x, as x to the fourth times x to the first. Now the first part, since the index is a 2, 2 goes into 4 twice, so it simplifies to x squared. The second part, you cannot simplify the square root of x, so it simply remains as the square root of x. And root x to the fifth simplifies to x squared square root of x. Let's try another one. We have the square root of y to the ninth. So I rewrite y to the ninth, which is really y times itself 9 times, as the root of y to the eighth times y to the first. The first root, since the index is a 2, 2 goes into 8 4 times, and it simplifies to y to the fourth. The square root of y does not simplify, so you just leave it there. So the square root of y to the ninth simplifies to y to the fourth square root of y. Here's an example with a cube root. Now the index is 3, so we want 3 to divide the exponent. We rewrite y to the 10th as y to the ninth times y to the first. That way the first part, the index 3, does divide the exponent 9 3 times, so it simplifies to y cubed. And then the cube root of y does not simplify, so it just stays as the cube root of y. There's one more example with the cube root of y to the eighth. Y to the eighth is y times itself 8 times, so I rewrite it as y to the sixth, which is divisible by 3, times y squared, which is not divisible by 3. So the first part simplifies, 3 goes into 6 twice, so we have y squared, and the last part does not simplify, so it just remains behind as the cube root of y squared. This same approach will work even if there are multiple variables within the same root expression. For example, the square root of 8x to the 7th y to the 5th. First, you have to rewrite each number and variable inside as a exponential expression. So 8 is actually 2 cubed, and x to the 7th and y to the 5th. Now I break apart each base to have 2 parts. One part that is divisible by the index number, like 2 squared times 2 to the first, and x to the 7th is really x to the 6th times x to the first, and y to the 5th is really y to the 4th times y to the first. That way, there's one part where the exponent is divisible by the index number, such as 2 squared x to the 6th y to the 4th, and I bring all those out front to be simplified. And then all the other parts that have exponents that are not divisible by the index, like 2 to the 1st, x to the 1st, y to the 1st, I put those at the end of the expression. Now all these first components will simplify, because the index 2 divides the exponent. Oops. Oh, I see what I did here. I did not group the terms that way. I apologize. Let me go back. Here is the even exponent, the even exponent, the even exponent. Those all simplify, and I bring them to the front of the expression. Whereas here is the odd exponent, odd exponent, odd exponent, and I bring those to the end of the expression, and I leave them inside the square root, because they did not simplify. Let's try that again. Here's a cube root. I rewrite the 16 as 2 to the power of 4, and then I notice that each of these exponents is not cleanly divisible by 3. So I break them into two parts, one of which is divisible by 3 and one of which isn't. So for instance, 2 to the 4th. I rewrite it as 2 to the 3rd and 2 to the 1st. The first part is divisible, the exponent is divisible by the index number 3, the second part is not. Likewise, x to the 14th becomes x to the 12th, where 12 is divisible by 3, and x squared, where 2 is not divisible by 3. And the last part, y to the 10th, is rewritten as y to the 9th, which is divisible by 3, and y to the 1st, which is not. Now I break apart all of these individual expressions using the product rule, looking at each one individually to see if it's simplifiable or not, and I bring all the simplifiable pieces, namely those whose exponents are divisible by the index, out front and simplify them, and then all the pieces that are not simplifiable, because the exponent is not divisible by the index 3, I leave them inside the cube root and leave them behind. Here's a final example to consider. When you're ready, go to the next screen. Here are some practice problems. Notice that the next screen has the answer key. Thank you.